So the last two presentations are more broader overarching looks at sort of our modelling capabilities, modelling trends and so on, one from a North American perspective and one from a European perspective. So I'm very pleased to welcome the first two of the speakers, Dr. Rick Donnelly from WSP Parsons Brinckerhoff, who's going to give a North American perspective about modelling and modelling futures. So thank you very much.
Am I on? You can hear me. This is sort of intimidating because everyone else before me says I'm not a modeler. And I am. And also I've been asked to cover all of North American modeling in 15 minutes. And we just had a conference that took 2 days. So you're going to have to listen fast as I blow through this. So, whoops, wrong way. There's North America. And we have 4 modeling programs kind of in play in North America. 3 of them are kind of traditional and established. And you've already seen trip models and are pretty familiar with that paradigm, so I'm not going to spend any time on it. But we're into activity models in a big way in the USA. And we start out with a population synthesis, and then we do some long-term choices with that. Auto availability, your work and your school locations, and from that we go down and we get daily activity patterns and then the tours that emanate from them. And then we usually have some sort of a tour scheduling program that arranges those tours in time and space and to include the mode that they're going to use. And finally, we make some trip choices. For example, you might drive to and from work, but you might take transit to lunch or drive in a company vehicle to go to a meeting. And we still run them through the same kind of traffic assignments that we have been doing for the last 60 years with our trip-based models. And then the third kind of model that we have is an integrated land use transport model. And so if you take this entire thing here and squeeze it down into one box, you get the idea of the complexity of this thing. But basically, we're taking accessibilities and disutilities on the transport side, and we're putting them into residential and business location and transition models, and then we use some sort of a bid rent model to clear the market. And this thing staggers through time in 1-year intervals. One thing to note about this is that our trip-based models are all aggregate equilibrium models, but all of these models, with one exception here, are all microsimulation models. And we think that we get more benefit out of the microsimulation in some respects than we do actually the modeling paradigm that's implemented in it. An activity-based model produces a list of trips that are fully attributed that look a lot like a household travel survey because they, in effect, are building a synthetic household travel survey of the entire population. And so with microsimulation, we can mine that kind of data. It also sort of forces us to confront variability in our data head on, rather than just conveniently tucking it into error terms and constants in our model. And the third thing we do is we're able to use this kind of approach in order to do multi-scale modeling, where you can pull information from various levels and feed it back up. So in North America, most of our states have a trip-based model. We have a couple here that you see that are shaded that we have activity-based models. And in about 24 places, we have operational activity-based models. These are in addition to the ones that we're using in R&D and academic settings. And there's a lot more of them in development as we speak. And if you can imagine a swarm of 300 dots layered over the top of that, that would be kind of the coverage of our trip-based modeling. We've had kind of a disjointed development along it. Like you, we started out on mainframe computers doing trip-based modeling, and we primarily spun them up anytime we needed to study a mega project, but otherwise probably didn't use them very much. We had kind of a drought in the 80s, and then with the advent of the microcomputer in the 90s, boy, it really took off. And as you can see right here, most of these are trip-based models. And if you're in the back of the room, you can't even see, the crust up here that is the activity-based models and some of the other advanced models. But the rate of growth of these things are kind of incredible. Unfortunately, not only are the models more sophisticated, but so are the data that go into them. When we build a trip-based model, for example, we only use a few categories of employment. And when we get to an activity model, maybe we use like a dozen. And when we get to an integrated land use transport model, we're modeling the economy at the same level as the macroeconomists do. And so that brings some challenges unto itself. So why do we do this? Well, there's kind of a push and a pull. So the pull is the fact that policymakers are starting to ask a lot of questions that we cannot even begin to address with a trip-based model. And some would argue maybe not even with an activity-based model. So in a lot of places, a trip-based model is totally fine if you're dealing with things that you can measure in terms of travel time savings and the typical network metrics that we put out. But in a lot of our model applications in large metropolitan areas, policymakers are starting to ask us to tell them about pricing and equity and making very complex transit choices. And of course, it's no secret to this crowd that AVs and mobility services are a big thing on their mind. And they recognize that you need a more sophisticated tool to be able to do that. And moreover, in Oregon, where we've been doing integrated land use transport modeling, and the models have been operational for about 15 years now, we've gone through 3 cycles of major requirement changes from clients. In fact, we're almost getting to the point where their requirements for what they want to have input on and the things that they want to test are morphing faster than we can recast our models. So that requires us to think about a different kind of modeling approach. We have kind of a history. We started out on mainframe computers, and we still do trip-based making like you did. But a couple of things on the push side of innovation that has really influenced what we do is are kind of illustrated here. One of the big ones is that around the end of the 1990s, our federal government stepped away from a leadership role in travel modeling. They still do R&D, and with one exception, though, they don't really set standards or expectations in the field of modeling. So our modeling community has more evolved as, I guess, scientific consensus and a little bit of one-upsmanship in terms of what kind of capabilities come around. But in the late 90s and the 2000s, we had several big research projects that taught us something about microsimulation, about agent-based modeling, the opportunities for parallel computing in these multi-scale models. But the real thing that really hit us was in 2007 when our Transport Research Board came up with a blue ribbon panel that said, well, for most of what we expect to be informing policymakers on in major metropolitan areas, the trip-based models weren't up to it. They not only weren't up to it now, but from what we could tell in the future, they were even further out. Since that time, we did a little bit of research that told us that reliability, the value of reliability, is at least as important as the value of time when you're looking at traveler responses to pricing and congestion. And that, of course, is another thing that we could do in microsimulation that we can't really approach well in a trip-based model. Big data finally arrived, and of course, connected and automated vehicles are going to change the world, and the mobility services that leverage them. Most of these advances aren't going to help us model that paradigm. And so we're almost starting with a brand new page. We're going to take everything off this page we can, but really it's going to be a challenge to redo our tools to do that. If you were a critic, and there are no shortage of them, you would say that one of the things that we've not done so well in America is maintain a holistic focus on what we're trying to do. We have a lot of people that are really obsessed with the models for their own sake and the code they're implemented in, and they've lost kind of track of the bigger picture. And the bigger picture to me is that we say, well, we have policymakers that we want to usefully inform, and usually what they want out of us is forecast. So we need to look at this bigger picture, and we're only starting to focus on the left-hand side of this thing here. And I'll show you an example of how we do this. Dr. Collins threw this up earlier. We use the same sort of thing. Most of our policymakers are really onto the fact that there's no steady state future out there. And indeed, when you get investment bankers in there, as we increasingly do in the US, they want to see the whole range of possible futures out there. We've kind of taken the preposterous stuff off after our last national election, but basically we use the same sort of thing. But seriously, the reason that preposterous came off of there is that a few years ago, when you were talking about fully automated vehicles, that was still science fiction in the mind of most policymakers. They had no time or interest in talking about it. Now today, they can't stop talking about it, and and they realize that it's coming even faster than they thought it was just a few years ago. So when you're looking at the forecasting and you say preposterous, we say, no, I don't think it's there. The other thing that's changing is just the availability of data. All of my career, we've done traditional household travel surveys to inform our models. Great for cross-sectional models, and we've layered in a couple of other data sources below that. But our future is more in looking at passive data that we collect from cell phone and other Internet of Things devices, maybe added in, fused with some state of preference survey data to understand our population better. But I think that is forcing us to rethink how we build our models. And in fact, even just building on this, as a practical example, one of my colleagues, Josie Kresner, one of the sharpest young people in travel modeling in the USA, decided she was going to think differently about building a model for a place called Asheville, North Carolina. And we did this because it was a great comparison case. But she built a data-driven model that we hope is the future of modeling in America, where instead of using census data, we actually use consumer reporting data to build a synthetic population. We fuse that with data about firms and where they're located. And we have this data set that we call AirSage, by the name of the same company that puts it together. We have the luxury in the US of having two cellular operators that between them control 80% of the market. And so when you get that kind of sampling going on, you can do some amazing things, even if it's only origin destination matrices by major trip purposes. We also have the National Household Travel Survey, which is not large enough to build a model with in any one given place. But when you start looking at similar places across the country, we were able to pull out tour patterns. And so what Josie did was she wrote a discrete event simulation that basically fused those tour patterns with the local OD data from the AirSage. And miraculously, this thing replicated traffic patterns within the Asheville area, as well as a model that we had built up here, a traditional model that had taken 9 months to put together in an order of magnitude more money and going out and doing a traditional travel survey. But the real kicker is that she and another bright star that we have, Greg McFarland, did it in 2 weeks with 150 lines of Python code. Now, granted, they'd played with these frameworks before, and so they kind of knew what these third-party packages did and how to exercise them, but that's the whole point. The point is we're able to put something together, and that if this were done for real, she'd have 8 months and 2 weeks longer than the traditional model team would have to look at sensitivity in their data, to think about new futures, and to put together forecasts and answer policymakers' questions. And the reason that this is important for us is that it is kind of in the line of where we'd like to see modeling going, and where many of us are impatient to get to, where modeling becomes a more inclusive process where you have a broad number of decision makers, expert panels, decision makers, Delphi panels and everything that help define the range of things that we're going to test. And we run them through a model, kind of like Josie's, but we don't just run one of them. We run 60 or maybe 120 different simulations, and we're looking for patterns. And this is our fourth kind of model that we call as a pattern-based model, where you're using AI techniques to get an idea of what works and what doesn't work. Because most policymakers now in these large urban areas, and every last investment banker that I've had to deal with, they all want to know, well, of all of the different futures you can contrive that look plausible, how many of them does my project survive in? And how many does it go up in flames in? Because I want to choose something that's going to survive most of the futures that might be out there, and we already know that you have no more of a clue than we do about what the future is. And then once we do that and identify some of them, then we run them through our traditional models to look at the design and operational aspects that we can't touch with a data-driven model. So that's where we'd like to see it go. So what are our problems? Well, we need a major refresh in mindset as well as skill set among our practitioners in order to be able to do that. Part of it's bringing in new blood, but of course, a lot of it is just people in this room learning to do new things. Another problem we have is we need transparency in big data in a big way. we have a lot of people in the States that are moving into the big data arena where they have a small sliver of data from one particular app or one particular carrier, and they collect data for a year. And then they say, oh, this is big data too. Well, it's not really. And so we need that. One thing we need to do in the USA, and I hope that you don't fall into this trap, is that we've really gone down the reductionist rabbit hole. And what I mean by that is we just build these successively more behaviorally detailed models, and we get successively less and less benefit out of the additional data and out of the additional work and the complexity of the models. And in fact, we need to model a lot less and forecast a lot more. In other words, being able to talk about the likely patterns and how the behavior that you can measure today is likely to change in the future rather than understanding the nuances of it today. And we think we have a lot of tools that we can do that with. And finally, our approaches now are embracing uncertainty, whereas we just ignored this stuff as recently as a decade ago. So there's uncertainty in model parameters and uncertainty in futures, uncertainty about what we don't know about the behavior. There are statistical tests that are out there that we can look at to look about it. But the biggest factor, the biggest uncertainty that is ripsawing us in the USA right now is Google, because they have, unquestionably the best big data source out there. They've been able to fuse it with spatial data, and they have the wherewithal to do some really cool analytics with it that none of us can even begin to touch because we don't have either the wetware or the hardware to do it. And until they decide what or if they're going to do in the market, we're going to do second best, I think. But if there's nothing else that we've succeeded at in North America, it's doing well with not as much data as we'd like. That's my story. When you get the slides, I've got a bunch of things in there you can go look at if you're more interested in what we're doing, but I'm done.